वेलकम बैक। मैं अजय पांडे आपके लिए लेकर आया हूँ इस क्लास में क्लास 10th के चैप्टर 2 का फुल रिवीजन। मैं अजय पांडे अपने सॉल्यूशन ऑफ लाइफ अजय पांडे चैनल में आप सभी का स्वागत करता हूँ। तो चलिए हम स्टार्ट करते हैं आज की ये नई क्लास। So in this chapter we are talking about the refraction of light through a glass prism and what are the natural phenomena such as atmospheric refraction and scattering of light and their related some application. So in first chapter, that means the last chapter, we are already talk about what is the refraction through a glass slab. So here we are talk about refraction of light through a prism. So when we say about a glass prism, so we get an image of triangular glass prism. And what is the triangular glass prism? So triangular glass prism is a three rectangular sides, and this is called a lateral slide, lateral, and two triangular ends. So there we are talk about triangular glass prism. So the next, what is the refraction of light in case of glass prism? So firstly we are talk about this diagram. So here incident ray act at this point, and so here rays is going from a air to glass. So when the light ray is going from a rare to denser medium, so it bend towards the normal. So look at here, this is a normal, this is your normal, and a light ray is bend like as. So after that it's when it going from this point, again it's refracted, and now this time is going from a glass to a air. So this time it refracted toward away the normal. So here this is a ray. So first ray that's coming on the surface A and B is called incident ray. Second ray is going from the glass is called refracted ray, and the finally is coming out from the again in the same medium is called emergent ray. So emergent ray making an angle from normal is called angle of emergence. Incidence angle is what? Incidence angle is making from an incident ray from the normal, and the refracted ray is making an the angle from the normal is called angle of refraction. Okay, yes. So another very important definition, that is what? So here we look at emergent ray and incident ray meet at point O. So that is make an angle is called angle of deviation. That is a what angle? That is a angle of deviation. Okay guys. Okay. So here look at angle made of emergent ray with this incident ray is called angle of deviation. Okay, we start the next point. When the light rays is going from a glass prism, so it get split into the 7 color components or its colored component. So when a white light passing from a glass prism, it divide into its 7 color component, and this is a form of Vivgure. So look at here, this is a form of Vivgure. And what is the Vivgure? Look at this is. So Vivgure is first violet, indigo, blue, green, yellow, orange, red. I think you all are know that. So it is a increasing order of wavelength. It is an increasing order of wavelength. So it is a decreasing order of what? Frequency. Okay guys, so when it is a increasing order of wavelength, so that is the same for the decreasing order of frequency. Okay guys, now what is the dispersion? So dispersion is simply splitting of white light into 7 different colors component when it is passed from a glass prism is called dispersion. So these 7 colors are Vivgure. So color change कर लेते हैं हम लोग. This 7 colors are Vivgure. So I am already talking about it is a increasing order of wavelength. So what is spectrum? Very important definition. Band of colored component is of light is called. So band of a colored component is called spectrum. Look at here. So this is these are the bands. The small width of the colors is called spectrum. Okay. So what is the causes dispersion? So white light combination of the seven colors, we all are know, when it is going from a prism, its medium will be changed. So its medium will be air to solid, hence different color at different angles. So that causes a dispersion of light. What is the recombination of light? So this is a experiment done performed by a Newton, and they put the two glass prism, one is erect position and another is a inverted position. So when a white light is going from a first prism, so it get dispersed and divided into a seven colored component, and the another inverted prism get recombined these seven colors and make a single line, that is called a white light. Okay, so that is performed by a Newton. You know that Newton is a great scientist in physics. So what are the application of a dispersion of light? So a very important application in our daily life, that is a rainbow formation. So guys, look at in this picture. So rainbow formation is really look like as. So let me start how it is formed. So in our atmosphere, where many few raindrops are available, so when a white light coming from a sun or any other things, so it form at a point, so it is going from a air to a water droplet. So it going from a rare to denser medium, so it get refracted and dispersed, because here the rain droplet work as a glass prism. So it get dispersed, and in this point guys, here this is a total internal reflection. What is? So at this point TIR, total internal reflection. So after that, once again it incident at that point and refracted and make an formation of rainbow. So we are already talk about the rainbow formation. There will be a three responsible phenomena. The first one is refraction and total internal reflection and the dispersion of light. So for rainbow formation, these three phenomena are responsible. When we are talking about major phenomena, then there will be a dispersion of light. So we are talking about the next topic is atmospheric refraction. So atmospheric refraction is a simply identified with the refraction of light due to a different layer of earth atmosphere is called atmospheric refraction. So there will be a refraction, a phenomena due to a different mediums, but here the refraction phenomena occurs due to a different layers of a atmosphere. So when the different layers of, we are talking about the when the different layers of atmosphere, so there will be a different types of mediums, that means the different variation in the density of that layer. So for these phenomena occur due to a atmosphere. So there three examples or with three application of twinkling of stars. Stars appear higher than they actually are, advanced sunrise and delayed sunset, and these three phenomena are the more important for the atmospheric refraction, and these three more times asked in a board examination. So let me discuss about one by one. So what is the twinkling of a star? So firstly, this change in intensity of light coming from the stars is called twinkling of a star. So the light is coming from the stars is intensity is the change due to the different atmospheric particles. So what is are the particles? So in the air, different types of density variation in the atmosphere. The optical density of air continuously change from one moment to another. So when atmosphere refracts more starlight towards us, star appears to be bright. And same things when the light rays is coming from the stars is uh, high, so they are brighter appear, and when the light rays is coming from the stars is low, so they are appear dim. So that is the phenomena why the twinkling of stars, and the mainly is causes by the atmospheric refraction. So the next, the stars appears higher than they actually are. So guys, a very important thing, where we seems to the stars, so they are not actually there. They are the some higher position from that actual position. So starlight from a vacuum in space to air in Earth's atmosphere. So as we move towards the Earth, this air becomes more optically denser. So that is refractive index increases as we move closer to the Earth. तो जैसे जैसे हम लोग अर्थ की तरफ आते रहते हैं तो रिफ्रैक्टिव इंडेक्स अर्थ का इंक्रीज होता चला जाता है. व्हेन स्टार लाइट एंटर्स द अर्थ एटमॉस्फेयर दे बेंड. तो जैसे ही स्टार लाइट अर्थ एटमॉस्फेयर में एंटर होती है तो बेंड हो जाती है, जिसकी वजह से स्टार्स जो होते हैं वो अपनी एक्चुअल पोजीशन से हायर पोजीशन पे दिखाई देते हैं. क्लियर स्टूडेंट्स? आई होप यू आर अंडरस्टैंड. लुक एट हियर, दिस इज द एक्चुअल पोजीशन एंड स्टार सीम्स टू बी हियर. Okay guys, so the next one is before at explanation for advanced sunrise and delayed sunset. So same things are the advanced sunrise and delayed sunset. This is an line of horizon, and here a person that is a observe. So sun is actually here, but due to the different atmospheric layer it bends. So sun is a star, it's looks a higher position where it is actually are. So this is called advanced sunrise. So sun's rays are coming from more denser towards the less denser. This causes sun rays to refract and appear to come above the horizon. So that is why the advanced sunrise. And look at in this diagram, and similarly same things for the delayed sunset. Sun's rays coming from more denser towards the less denser. This causes sun rays to refract and appear come above the horizon. So we can say sun is not sunset there, and we feel that the sun is there. So that is the delayed sunset and advanced sunrise. Look at in this diagram. Okay guys? Okay. So the next topic and the very important topic is of this chapter is scattering of light. Scattering of light means throwing of light particles in all possible directions, and that is what scattering of light. So look at here in this diagram, incident light rays is coming and fall on this black object, and this observe the light rays and scattered in all direction. Okay guys, so this is a scattering of light. So that means the propagation of a light in all direction is called scattering of light. Another phenomena is on the basis of scattering of light is called Tyndall effect. Okay guys, so what is this effect? Is the scattering of light by particles like dust, water molecules, and smoke, and fog, and some other like it. So we know that the atmosphere is a mixture of several gases, dust particles, smoke, water particles, etc., etc. So when the sunlight falls on the atmospheric light, particles get reflected from surface of these particles and get scattered in different direction. So that is another example of scattering of light. So look at in these pictures, there are light rays coming from the some holes and the windows. So these making a path of light. So that is a Tyndall effect. Another pic for this example, in the denser forest. So look at these types of light rays is called Tyndall effect. So why does the sky appear blue? And this is a phenomena mainly due to the scattering of light. So we all are know that the sunlight contains 7 colors by Vibgyor in the form of Vibgyor. These are here. So when the sunlight is coming from the sun and fall on a sky, So what are there? They are scattered the light by the clouds droplets. So in this diagram we can say that atmosphere scatters only blue light, because the blue light have a low frequency and easily scattered from the atmosphere. So when sunlight fall on molecules of air present in the atmosphere, they are able to scatter light of shorter wavelength, and we all are know that blue light is shorter wavelength than red light. So other wavelengths like red, hence scattered light is blue color, and hence we see color of clear sky as a blue. Okay guys? Okay, so let be the next topic. uh, Sun is directly above the uh, above at our head during the afternoon, so light rays from the sun take lesser time to reach us, so there will be a less scattering of blue light. That's why sun appears to be white. This is a question in asked your latest CBSE sample paper. So same things, the during morning and evening, why the sun is appear reddish? So light rays from sun take more time to reach, hence there is more scattering of blue color of sunlight, which is a shorter wavelength. Hence we are able to see red colored sun, because there is less scattering of red color. So red color having a longer wavelengths, so that's why we seen a reddish color of sun at during a sunrise and sunset. But at the time of noon we can see here the short path, and during a sunrise and sunset it's travel a longer path, so that's why we appear reddish, and the morning noon time we can see it as white color. Okay, I hope you understand this class. If you like this class, so please like and subscribe my channel. And if you have any doubt, so comment in the comment section. We will take a new class for that doubt. Thank you friends. Good night.